Okay, in this video I hope to explain some important concepts in mathematics and then to talk a little bit about polynomials. So first, in mathematics it is very important to learn these four things, and unfortunately they are often neglected both by teachers and by students in the mad rush to solve as many problems as possible and to get ready for the test. But the test is not actually what's important if you want to make progress in mathematics over a long period of time. You must learn the vocabulary, the words that we use. You must learn the notation, the symbols and signs. You must also learn the definitions. This is very important. And you must understand mathematics conceptually and try to understand the concepts. And usually a visual approach is very helpful when we are trying to learn the concepts of mathematics. So let me just give you an example. Here is a statement that is true in mathematics. The slopes of two perpendicular lines are negative reciprocals. And you can immediately see that the picture helps you to understand this, but I would prefer to give the definition like this. M perpendicular is equal to negative 1 upon m. So you can see there's a lot of vocabulary, notation, concepts, and a very important definition here. As a matter of fact, the definition, I would say, is on the bottom there, that it's always better to give a definition as a formula if possible. Okay, so let's look at another definition. Given a line y equals mx plus b and 2 points on the line x1 y1 and x2 y2, the gradient or slope of the line is defined as m equals y2 minus y1 upon x2 minus x1. So there's a lot here, okay? There's a lot of vocabulary, there's some notation, there's a lot of notation actually. There's some standards, there is a definition, a very clear definition, a precise definition, which is how we like them, and there's this concept of gradient or slope of a line. So let's just look at them a little bit more carefully here. First of all, the best way to write a definition is to write it as a formula. So it's much better to say that the slope of a line is y2 minus y1 upon x2 minus x1 than it is to say the slope is equal to the steepness or the inclination or the rise or something like rise over run or something like that. Because words can be very ambiguous in mathematics, but definitions such as this are very clear and unambiguous. Secondly, let's look at this. By the way, the word gradient is British English and the word slope is American English. Both are widely used and both are acceptable, and these are two different words to say the exact same thing. I think most students in high school, particularly in a place like India, will be familiar with both words and will need to recognize both words because most of you will be taking exams in either the Cambridge or the IB system, and you will see the word gradient, and you will be taking SATs as well, and you will see the word slope to mean exactly the same thing. So unfortunately, as I said, words can sometimes be ambiguous. That's why we prefer formulas for definitions. Lastly, let me point out that this is called a subscript, that small 2 there. Subscripts are used for labeling. So what this small 2 is telling me is that this is the second y in a sequence of y's, and sure enough you can see the first y over there to the left. And the subscript has no mathematical function except for labeling. It doesn't multiply the y by 2, it doesn't multiply the y by itself, it has no mathematical execution. It's just a label. Sometimes we say y sub 2 to make it very clear that it's a subscript, but many people will just call this y2, all right? Now that's important because you need to know that x2, x3, and x4, or x sub 2, x sub 3, and x sub 4, refer to the second x, the third x, and the fourth x in a sequence of x's. So there you see a list of x's, and the subscripts are used to label the x's. That's what they're for. Now, you know, by the way, let's read this. x1, comma, x2, comma, x3, comma, x4, comma, x5, comma, x6, and so on. Or some people will say dot, dot, dot. That is a mathematical symbol there, those three dots, meaning that it just goes on, okay? It goes on as you would expect. So obviously the next one would be x7, then x8, and so on, but we don't have to write those because we would be writing for the rest of time. So we apparently have an infinite list here because there's nothing that comes at the end of these dots. And x2, x3, and x4 are the second, third, and fourth values in this list. Now contrast that with x squared and x cubed that are completely different animals. Note that we say x squared and x cubed. We cannot call these x2 and x3, as many students often do, because x2 and x3 have a different meaning. They mean subscripts. So we say x squared and x cubed. And of course we have definitions, and definitions are best written as formulas, so we can say x squared equals x times x, and x cubed equals x times x times x. Notice that these are superscripts, and they certainly do have a lot of mathematical power. So x cubed, as I just said, is x times x times x. You must multiply x by itself and then multiply by x by itself again. All right, so let's look at this concept here of perpendicular lines a little bit more closely. What I'm going to do is I'm going to graph these perpendicular lines in GeoGebra. So let me go to GeoGebra. Let me just open a new tab, GeoGebra, and start the calculator. And let's recover our unsaved changes. That sounds good. And let's start a new. I have one already. Perpendicular lines. Okay. So here they are. All right. Let's just do this. Okay. So I have here these two perpendicular lines. Let's look at them a little bit more carefully. All right. One of them is y equals x minus 3. Now, you can see I've used some sliders here. Sliders are very useful in GeoGebra. So I've set the slider equal to 1. I could set it equal to 2. So now I have y equals 2x minus 3. Now, as I said, we're interested in definitions, in concepts, and vocabulary, and in notation. Now, when we're looking at the slopes of two perpendicular lines, or negative reciprocals of each other, it's nice to be able to look at a picture and to understand this conceptually, okay? So what I'm going to do is I am going to change the slope of the line. Now look at the blue line here. The blue line is increasing, so it has a positive slope. And if I make it increase faster, it still has a positive slope, but now the slope is higher. If I go all the way up to a slope of 4, for example, look at the slope of 4 here. Oops. There we go. I can see that this blue line is increasing. As I go from left to right, it's moving upwards. The perpendicular line which of course meets the blue line at a right angle, is decreasing. So the perpendicular line has a negative slope, while the blue line has a positive slope. So that's the idea of the negative. The slopes are always going to be the negatives of each other, or at least the negative reciprocals. But if one is negative, the other is positive. If one is positive, the other is negative. Look what happens if I change the slope of the blue line now, and I make the blue line decreasing. Now the blue line is decreasing, and what's happening to the green line? The green line is increasing. So here I have f of x equals x minus 3 as my blue line, but g of x equals, f of x equals negative x minus 3, so the slope is negative, and over here, the green line, the slope is positive. If I go a little bit further, if I make it more steep, f of x equals negative 2x minus 3, then the green line, the blue line, is steeply decreasing. It's decreasing rapidly, whereas the green line is increasing more gradually. And the steeper I make the blue line, the more gradual becomes the green line, the perpendicular line. So this idea of steepness in the original line makes gradualness in the perpendicular line is the reciprocal. So when we say that, the original line has a gradient of negative 4, the negative reciprocal is 1 upon 4, we can see how conceptually and geometrically these ideas are related. And look what happens if I move around the slopes. So let's get back to a slope of 2, and of course in the perpendicular line you will have a slope of negative 1/2. So now I have a better conceptual understanding of what I am trying to learn. So in the next video I'm going to talk a little bit about polynomials, and we're going to apply some of these ideas to polynomials.